so this looks a little scary, but it's not that scary at all, actually. What we're going to do is we're just going to break everything up because you're taking the derivative of all of this. So, first step, break everything up. Okay. I'm going to take the integral of, or antiderivative of pi e to the x. We're going to take the antiderivative of negative 2 sine x. What you can do here is you can take out your negative 2 and put it out here because that's a constant. But this only works when you're taking your antiderivative of basic functions. If it's like negative 2x squared, you're going to want to keep your negative 2x squared all together. But if you have it in front of a basic function like sine x, cosine x, take it out and just solve for sine of x for the time being, dx. Then 1 dx. Okay, so let's just take the antiderivatives of this really quickly. So what is our favorite basic function, e to the x, because it was always the same. So what you actually started with here was the same exact thing to get this, remember? Because that was our rule. Okay, so pi e to the x plus c. Don't forget that. Okay, what did you have to get sine of x? You had negative cosine of x. And now at this point you can bring back your constant, so times negative 2. So this would just also equal 2 cosine of x plus c. Okay, and now we have this. Now, I want to know what you guys thought. I mean, when you take the derivative of a constant, you get 0, right? And so when I first did this problem, I wrote this down as 0. And then I was like, wait, no, that can't be right. That can't be right. There's something wrong. Well, remember, this is antiderivative. So we're taking what we started with to get this. So we have to have a function to take the derivative of it to get 1. So we'll just start with writing down x. Okay. In order to get 1 from x, it had to be x to the 0 at the end of all your work. So to take the antiderivative of it, we can just do x to the 0 plus 1, and you can bring that value down. This equals x. So what you had was you started with x to get 1. Of course, we could check this. dx of x equals x to the 1. You bring the power down first, and then you're going to subtract 1 because we're doing power rule. So you have 1x to the 0. X to the 0 equals 1, which equals 1 times 1, which equals 1, which is what your problem was. And now you have what you started with. So you started with x plus c. Okay, so you just found all your antiderivatives. Now all you have to do is just put them back together. Okay, so your final answer is going to be, I'm going to write it here. Final answer. So we have pi e to the x plus 2 cosine x plus x plus c because of your family of antiderivatives. And this is your answer. And that is the journey of antiderivatives. That was my rant on antiderivatives. I guess it wasn't really a rant, so I guess that makes me not Kiva rants and Kiva teaches. I don't know. Should this be Kiva teaches? Maybe not. We don't know. But thank you guys so much. That was my rant. What did I just say? God.
Your closing line.
Yeah, Kiva just ranted, and that was very awkward. That's what I forgot at first. I almost said that was a rap, like Saruman, but it's not that. That was very awkward. Bye, and I'm sorry for not making videos for so long, guys. This is hard. I'm doing calculus now. This is hard. I don't have time. All right, so that was it. Bye.